So we're starting this pretty early because I've got other things to do today. And we've got a Maxon rather than Maxcom. Maxon is the parent company. MX2000, which is a CEPT FM only set. I thought we were going to be doing a multi-norm Maxon, but it wasn't the case. It was this. And this, like the Radiomobile, I understand is a brand new set. And what's these, from 1987-ish? The only idiosyncrasy these have is these buttons, these push buttons at the bottom can fly off. So always be careful how you let those buttons return so they don't fly off and go disappearing. I think we're going to have to see one of our friendly 3D printer people, because I think I have two of these sets with most of the knobs missing. So we're going to do the same precautions as we did for the Radiomobile. It's a bit newer, it might work. So I can see we've got an instruction book. Oh, and we've got the square kit diagram. I've probably got this anywhere, and I'll leave that to one side just to check. So we're going to have the original mic in here. I might have to use that, and I might not. Oh, it's 6-pin. I've probably got a 6-pin mic, test mic, because of course those 6 pins can differ from make to make. And it's a Uniden type of power connector. Now this, the way these are, it's not taped up or anything, so you know you can't kind of say I know that's brand new, but I mean it certainly looks like it's brand new, and they don't do seals. And I think quite a few of these were surplus because, you know, CEPT start off, oh, it's going to be absolutely wonderful CEPT, it's another 40 channels, and then you, certainly in this area, you put it on, you've got S8 of foreign interference. I mean, some people might think foreign interference is an opportunity to contact people overseas, but I can't see it, unless there's a bit of skip, and you're not going to do that very often on 4 watts. I have done it, I honestly have. When my late mother was alive, I was at West Willoughby, which is a mile from here, the opposite way than we have the on-the-air test. And I got a pickup truck at the time, and I got a centre-loaded Les Wallen Thunderbolt aerial and whatever CB, and I just couldn't get through to it. Oh, it'd be Baby Midland 104, and there's no reason why it isn't the same range as any other set. And I'd been trying to call her all the way back from Nottingham, and on UK channels I could have got in from Bottisford, especially when picking his spot. Well, I couldn't contact her, and I was absolutely solid. I mean, I could talk to her on a walkie-talkie from the hospital 6.5 miles away, because I'd done it. Got to West Willoughby and finally made contact, and there was a German on there, and he heard me loud and clear. So it can happen, which is the last thing I was trying to talk to my mother. So we're going to open this up for exactly the same reason that we opened up the Radiomobile 201, because when I power this up I need to monitor capacitors. We hadn't have done the monitoring of the capacitors on that Radiomobile, the 220 microfarad one in the transmitter would have exploded. And we've got one in the back on these sets. Apart from those knobs on the front, these have a really good quality feel to them. Oh, we've got a date. March 89. Did I say 87? March 89. I'll drop that down on the clipboard, which we haven't started yet. That's not the right one. I've put it in the out tray. It's taken from the out tray instead of the in tray. And it should say PR27GB approval on it, which it does. So I need to just find our Uniden power lead, which we've got on the bench lurking somewhere. It's one we've borrowed from stock. Just testing it for the customer, you know what I mean? I'd rather use one of ours than the factory original. But you know what? We need to just check that it's not a 3-wire one which has memory backup. This is the era where there was memory backup on some radios. Yes, it's a 3-wire one. We have to use the factory original 3-wire one because it has memory backup. And that's a rewirable plug. We've had some scrap Precision Series American AM illegal hear sets in the past, which have the Precision Series Midlands, made by Maxon. They've got a rewirable plug, and you could actually use one of those because they've got the pins linked in inside. So there we go, we're going to have to use the factory original lead. I've actually got one of these in stock new. That wasn't an advertisement because I don't think we're selling it. So we need 2 of these to positive and 1 to negative. The battery positive, accessory switch. The idea is that it retains the memory of what channel you will last on. So instead of it powering up on channel 9 every time, or whatever it powers up on, it will stay put. Right, making sure the set's off, which it is. I'm going to switch the power supply on at 9 volts, current limited to 300 milliamps. Now I'm surprised I've got no current draw at all, but I haven't, because it does have this memory backup. I'll switch it on. There was initial surge when it went over 300 milliamps, and it's stable now at 156. Right, I'll change the power supply to 12 volts with 280 milliamps gone to 17. I'll just take the lid off. take the speaker off and we'll start feeling things. At least you can see where I've put the lid with it being blue. It's crystal filtered as standard, because that was one of the rules with CPT. See, back in the 2781 days, in 1981, when they developed the 2781 system, they didn't take into consideration a minimum receiver spec, and that's why you got some not so good receivers like the Fidelity 1000 and and its great counterparts. So this is another of the reasons why you can't convert UK sets to be including the CPT, because this specification was higher, and it includes a receiver specification, and it's got much more filtering on the transmitter. And remember that the UK spec was much higher on its interference than the American FCC approved AM system, so this takes it even higher. Don't think we see more than 3.5 watts ever on these. Right, I'm going to pop it on 13.8 volts. So we're at full whack now. We'll select channel 20. It's a pretend rotary switch because it's up down. And I'll go and see if our microphone, our 6-pin standard microphone, actually works on this. In the meantime, we'll plug in extension. We'll do extension speaker first, then we'll test PA. Right, so I'm mistaken, it's 7-pin, which is the other standard mic we have, so we're going to have to use the factory original. So if we bought one of these sets which didn't have a factory original mic, we'd have to wire one specially, because it's a 6-pin mic. I'm not going to take this off the wrapper until I have to do the deviation. I'm going to put the wrapper back on, because I don't want it getting any scratch. It's a very nice flexible lead, this. Straight away we've got FM hiss, squelch operation. So let's go for PA. Swap my connector over. As a precaution, we'll plug the test gear into the aerial socket, just in case I press the wrong button and we go into transmit. So, oh, it's got a scan on it, has it? PA, it shows in the window as PA. Testing 1 2, testing 1 2 3 4 5. And it's got variable volume on the volume control. Not all sets with PA have variable volume, like the Uniden 100 for a start. So PA works. Doesn't have a meter lamp. Right, let's take that back to the extension speaker. You've also got external S meter. Out of PA, we're on channel 20. We're now going to put picture in picture on, and we'll see if it transmits. does, and it's beyond 3 watts. It's 3.1 watts. Channel 40. Watts. Channel 1. Shall we guess 3.1? Yeah. Now don't have low power because that's a 2781 thing. One of my favourite features. Do a quick deviation check. I have to reset the deviation meter because we're set for UK. Wallow. Looks like it's 1.8, but we'll test it on the other test set. We've only been on for 10 or 15 minutes. We'll just do a frequency check, but we're not going to align it until the gear's been on half an hour plus. It's actually right. 27,205.09. So it's just very, very slightly high. So that's great. If it stays put, we won't need to adjust it. So we'll go over to receive, and again I'll have to reset the signal generator. 27,205. And it was 205.09, so we'll get it exactly on the frequency the radio's on, to be totally fair. See whether we can hear anything. We can. So now I'm going to change the speaker on the wall for the test equipment, which is under my duster somewhere. Do we need an earth? No. Just a negative earth set. So right now we're on 100 microvolts, so it should read S9, which it does. Just go back to transmit because we never looked at the transmit meter. Full scale deflection. I just found this part of my little finger very, very sensitive to heat. Seems to be alright. Anyway, we're leaving it on an hour before doing any alignment. Right, let's go to the cyanide meter. .61. .49, there's a big gap there. Just does one. Squelch. Let's go over to the attenuator so you can see what I'm doing. So I'd like the squelch to open to 100 microvolts. 3 dum dum bum. That's 100. That's 300. Let's get it more accurately. It's 280. It's opening. That is all right, but I'd like it to be 100. If it's adjustable, that's absolutely fine. We'll put the signal generator to standby. I'll park it at 0.3 of a microvolt. Set the squelch. Signal generator back on. Ooh. Now that's awful. 5.2 microvolts. That'd be it. Oh, round scratchy corner. Something's not right in the receiver. Even sets with poor squelch operation, it's going to be 2.5 microvolts. I'm going to do that test again, just in case I didn't set the squelch right on the radio. So let's try again. There's the hissing. Very carefully move it to threshold. Signal generator back on. So that time I got it at 3 microvolts, but I was extra careful. That's still not good. So far that's all that's not satisfactory. So I'm going to come back in an hour and I'm going to feel these capacitors again. See you in an hour. Right, so here we are. Much later, 11:30. What I've done, we've got this on file. I didn't have to scan the customer's one, and I've got notes in this one. And the thing about scanning these high resolution, I'm able to print them out bigger, of course, which helps when it's minuscule anyway. I mean, I could print this out A3, but I think we're going to cope. We've got the circuit diagram, we've got some notes, and we'll start by turning the power up on its power preset. There's an automatic power control, and if I can find the trimming tool, which is right there, we'll get on with it. So the power control with a blob of glue on it is there. So just like on a cybernet where we set the power to absolutely full, then back it off to 4 watts, and manual says 3.8, but we back it off to 4 watts. We do the same with this, but it's with the automatic power control preset. So key it up, it's doing the, we're on channel 20, it's doing the watts we expect. So there we are, it's now actually doing 5 watts. So we've got to peak this on channel 20 to make sure it's in the centre of the band. And that means detuning it and to retune it. There's a slight difference there. There we go. What's under there? We've got another one under there. Right, and now we can drop the power to 4 watts. And as I've said before, legality aside, if you leave that at full whack, it will kill the radio. I would estimate 20 minutes. So channel 20, 4 watts, channel 1, 4.05. 4 watts, 4 watts, 4.05 watts. Never took the current down before. Anyway, it's 1.29 amps. Which was also an error because I should have had it on channel 20. It's 1.36 amps. Well, I think we'll do the power meter next, but there's a bit of a thing here. We've got two presets there, 101 and 102, and the circuit diagram says that they are TX meter, RX meter. But then the circuit diagram goes on to say they are squelch preset and external squelch preset. Don't you just hate it when that happens? I'm just carrying on feeling this to make sure. I don't think we've got anything dodgy. So shall we see? And the fact there's two together and it's not round the squelch circuit, we don't know what this preset is. It's not kind of there, which I think that's going to be squelch. That's going to be, we know that's deviation, and I think that it's going to be TX meter and RX meter. So key it up. Well, folks, not that one. I'm going to cheat. I'm going to drop the power to 13.8 volts. Oh, sorry, to 9 volts, so the radio can't work properly. Idea being, so we get, yeah, it's current limiting anyway. I'm going to have to take it to 12. See whether we can. So that's not making a difference at 12 volts, because the idea is we're now drawing less power, or generating less power. Oh, right, well, how many watts are we doing? We're doing 3.2 on 12 volts. This, you know, if you got low power, you'd be able to find this so much quicker. So I'm going to just skip forwards and see whether it is squelch. See, I think this is squelch. That's having no difference. So, theoretically, that's the squelch. The manual says so, but it isn't. And that would be external squelch, which it isn't. Well, this is fun, isn't it? That is definitely squelch. So they are definitely the power meter. So what I'm going to do, we're going to back pedal, because I'm going to have to drop the power. I'll still do this at 12 volts. I'm going to drop the power from where we've beautifully set it and drop it to 2 watts. And I'm hoping that we can adjust the meter now with 2 watts being generated. Yes, we can. That's the power one, just as we thought it would be. So, put the voltage back up. We're generating 2, the radio's doing 2 watts. So, we'll turn the radio back up to 4 watts. and of course it's now, oh, so it's now reading 3, so at least we've got some. Well, why didn't it do that when I turned it down? So there we are, just reading the 4. It's no good it banging across, which is what it was doing. That took some doing. Right. I think we'll do deviation next on the test set behind me. This off. Wow, it's 2 dead, exactly 2. So let's pop that to 2.2. Wow, there we go. And put the paper bag on its head again. I'll do that when I'm kind of half kneeling on the chair to get to the test set behind me. Turn that off, save some electricity. I'll tell you what, we'll just see where it is on this meter. Wallow. That's on the wrong scale. Wallow. It's reading low today. So the next time we take this bag off will be for the on the air test. I mean, I could make up a brand new test mic, but obviously it's got an expense to me, hasn't it? And it's not like this hasn't got a mic. Right, that's bagged up again. We'll make some notes, and we've got, it was 2.0 and it's now 2.2 to 2.5. We're not doing the VCO, we've got no method and there's no reason to. Knowing Maxon, it's done on a pin jig and you've got to add extra parts. I can just imagine it being like that. I may as well do frequency next. That was very slightly high. Everything's warmed up properly now, so let's see where it really is. 27,20524. So I'm going to pop that down a fraction. I'm not sure why it was so high. Trimmers there. Not that it would have made any difference, you know, it's all very within the tolerance. Oh, it's like that, is it? It's very, very finicky, this one. It's smooth enough, but the slightest touch and it's gone a long way. I've overshot it. No wonder it's slightly high. Now it's slightly low. It'll take me as long to set this. $499 toggling 500. $27,205. Right, so we'll now set. That's now 4. We'll now set the signal generator exactly to that frequency. go. And we'll start with the detector, because it could be that that's out, which is causing the squelch to be awful. So the detector is this one. Miles out. Wow. Right. Because of that, I'm going to do this in kind of reverse order. We'll do the IF first. So that was 109, 108, I'll put the cyanide meter up. I'm looking at everything. I'm looking at the oscilloscope, the cyanide meter, and the meter on the front of the radio. In fact, I tell you what, we'll change the sensitivity of the meter to help me. It's not easy. Try just with the cyanide meter. Slight bit there. That was miles out. You can see why at the factory, you know, they've got 10 seconds to go, read something on a meter down the conveyor belt. Right, we'll do the front end. So drop that right down to about 4 dB, and we'll do 101, 102, 103, 104, 105. That was spot on. That wasn't. That was miles out. Drop the signal. Fraction there. That was spot on. That was spot on. I'm going to go back to these at the beginning because they are interactive. Yeah, the very fraction on that again. There we go. Now I'll set the meter, which we now know is that preset, and it wants to be 9. and there we have 9, and then a bit further signal plus 30. So that's looks to be correct. So let's read off what we've now got on receive. And whether squelch is improved or whether I fixed it worse. I love that phrase. 0.35. I could say 0.34 and a bit, but I'm going to put 0.35. 10 dB. 0.28. 0.64. Look at what they say. Not that you know how they've done it. I don't know what a PSOHO filter is. I don't need to bother looking it up either. Anyway, they say for 20 dB it should be doing 0.5 microvolts PD. So they do say, well, let's switch the meter to PD. Well, isn't that fantastic? Because it is now doing, for 20 dB in PD mode, it's doing 0.31. So it's better than 0.5 in PD mode. We don't normally use PD mode because it's it's easier to achieve that. But of course, manufacturers are going to do that. So there we go, 0.31 for them. So it exceeds their specification. Good. So we've just got squelch to fiddle with. That will be fun. Right. Squelch to full. And I'll put this meter up. Not meter, attenuator. So I want the squelch to open to 100 microvolts. I wonder if it says what they want the squelch to open. What they want and what I want are different. You even get a wiring diagram, and you know it's quite handy when you buy one and somebody's ripped all the wires out to turn it into a amphibious landing craft. That was a good line, wasn't it? From Faulty Towers. What shape chips do you usually have at home? Amphibious landing craft shape. Does it say squelch? Well, that was a waste of time. No, it doesn't. Right, so here goes. We've set the squelch to full on the radio. 3, 10, 30, 100. It doesn't open. Now just check. 30, it's closed. 100, it's open. So I can now put 100 microvolts in that box. Now, have we got rid of this atrocious squelch figure? And I think the answer's better be yes. Turn the squelch down. Set to threshold. Signal generator on, parked at 0.3. Well, I wouldn't write home about it, but it's 1.3 at the moment. Now, we'll do that again because we did it. I'm in EMF mode. I've gone and because I was in PD, I've gone and I'll just start this again. Squelch to full. Right, this isn't. I'd set it in PD mode. Now we're in EMF mode. 30, 100. Right. So now we agree that is how it should be. Squelch now set to threshold. Signal generator on, parked at 0.3. Still lousy. It's 1.7. Well, that's the way it is. I mean, nobody would notice that. This is like, you know, when we do the on the air test, when he gets to the Kelbyton, I don't always get. He says, I'm at the Kelbyton, I say Roger on that, and he says Roger back to me to see whether the squelch opens. That is the squelch test, it's the Kelbyton. And we'll see what happens. Because half the Cybernet sets we do, the squelch doesn't open on that second Roger. So there we are. Right, well, I can feel some hot spots because it's, you know, it's drawing power, but I can't see any duff transistors, any duff capacitors. Nothing's played up. Yeah, it needed some alignment. Good grief, yes. I'll put the lids back on, and we'll put it on the aerial, and there won't be any good buddies out there. I mean, there aren't usually, are there, out here, but hopefully we can do an on-the-air test successfully without foreign interference, constantly changing channel. I genuinely think this is it's either a new set or it's a return, or, you know, which has been out of the box for 30 seconds. I mean, transmit was alright, but receive. If you'd got another set, you'd think this was not as good. That said, that 0.61 is certainly under 1 microvolt, and you know, some sets don't do better than that. Some other makes. Right, so let's put the screws back in. Using the correct screwdriver so we don't mar the screws. Put them in loosely. I'll tighten them all up at the end. Funny if somebody got back to me, wouldn't it? And they go, sounds like you got a bag on the microphone. Right, we can unplug the test gear. Internal speaker working. And we've got this little tiny self-tapper screw that goes in the back. I think these are a good solid set. They're not a flimsy set, and they're not an unreliable set. Right, aerial out, to the test gear that is, and we'll switch the test equipment off. We'll plug the Solarcon 99 base aerial in. I'll tell you what, we'll start by switching to scan. Well, that saved me going through, didn't it? Because nobody on. Always, yeah, if you don't see me, these local DX, it's only RF gain. So, if we press local, it'll just reduce the receive sensitivity dramatically. That's all that's about. So don't think it's some magic button which makes it work better. It's already in the best position. Channel 9. We've tried PA. So, we'll go through with the squelch down. Banana Roger. But we go back to that, there's a bit of a thing, go to DX, to local, and we've dropped the sensitivity. See? squelch on, and we'll put the bench dog tool thing underneath. So switches are okay, potentiometers are alright, sockets are alright, microphone's alright, speakers alright. Well, that's turned out a lovely set, but again, it you know, out of the box, it needed intervention. Thanks for watching the Maxon MX2000 CEPT FM set from 1989.